In this video, we're going to take a look at the equation of a circle. So the standard form of a circle is written as x minus h squared plus y minus k squared equals r squared. The center is at hk and the radius is equal to r. The basic form of a circle, we could call it our parent circle, is x squared plus y squared equals 1. So that's your very basic circle that's not shifted left or right. It's just centered at the origin and it has a radius of 1. And that is actually the equation of a unit circle that we're going to take a look at, of the unit circle that we're going to take a look at in a couple weeks. So let's take a look at some examples of just taking the equation of a circle and picking out the center and the radius. So in this first example, we have x minus 1 squared plus y minus 2 squared is equal to 4. We would say the center point is hk, but h is x minus 1, so h is actually 1. Because remember, our form of a circle is x minus h. So if this is minus 1, then h is just equal to 1. And then the k works the same way. So if it's y minus k and we have y minus 2, then k is just equal to 2. So if you notice that you have to change the sign of those numbers when you pick them out for their center point. And that'll work every time. And then your radius comes from the number over here on the right. And that's r squared. And so you want to take the square root of that number, whatever it is. If it's in standard form, you just need to take the square root of that number to the right. So the square root of 4 would mean that our radius is just equal to 2. Okay, so for example, 2 in that box, we have x squared by itself plus y plus 3 squared equals 16. So when you have x squared by itself, that means that that x value of your center point would just be 0. Think about there's no number added or subtracted to x. The only number that would work for that would be 0. And then the k value is negative 3. So 0, negative 3 is our center. And the radius, remember this number on the right is equal to r squared. So you've got to take the square root of that number. So the square root of 16 would just be 4. So our radius is equal to 4. All right, so in the next example, we have x minus 5 squared plus y plus 2 squared equals 18. So our center point would just be 5, negative 2. Just change the sign of those numbers. 18 is equal to r squared. So the square root of 18 would be our radius. And we could get a decimal, or you could simplify the radical. I'm just going to get a decimal. So I'll say that's equal to about 4.2. So our radius in that case is 4.2. In this last example, you don't have anything in parentheses right here with your x or with the y. So that just means your center point is just at the origin. So it'd be 0, 0 for the center. And then 25 is equal to r squared. So the square root of 25 is our radius. So the radius would just equal 5. Okay, let's look at a few more examples of different things involving circles. In these next two examples, we're going to pick out the center and the radius, and we're going to graph each circle. So using the same method we were using just a minute ago, we're going to pick out the center. So it would be 5, negative 6. Just change the sign of those numbers with x and y. And then your radius would be the square root of the 1 that's over there on the right side. Now to graph that circle, you need to go to the point where your center point is located. So go to 5, negative 6. So 1, 2, 3, 4, 5 to the right, and down 3, 4, 5, 6. So go to that center point and put a nice dot right there. Then your radius is 1. So you're just going to go 1 box to the right, top, left, and right. Left and down. Sorry, 1 unit, in other words, like in each direction, to show you have a radius of just 1. But that's all you need to do to graph your circle. Let's look at another example of that. So if we have x plus 3 squared plus y squared equals 4, our center point is at negative 3, 0. So we go to negative 3, 0 and put the center point on our graph. The radius would equal the square root of 4, which is just 2. So from the center, you want to go 2 in each direction and put some points. So let me erase that stuff so you just see my points. And then draw a nice circle as best you can to represent that circle. All right, so we just picked out the center and the radius and graphed our circles. The main thing to remember is just try not to accidentally go back to the origin to plot the radius. You want to go from the center point that you plotted first, and then use the radius to get those other 4 points. Okay, so for these examples, we're going to write an equation for the circle described, and we're going to look at 2 examples of if they just gave us some information in writing, if they gave us a graph, and then if they told us about a translation of our circle. So in the first 2 on this section, it gave us a center of 1, negative 4. So I'm going to write that out, and it gave us a diameter of 6. So we know the radius is half of the diameter. So I'm going to go ahead and write that down. Knowing my center is at 1, negative 4, I'm going to set up my equation. And then I'm going to remember what we looked at above here with the other examples. And I'm going to change the sign of that x value of the vertex, which is my h, and my k. So remember we have x minus h, which is going to be x minus 1 in this example, plus y minus k, but it's minus a negative. So that goes along with changing our sign. That'll be positive 4. And then r squared is what goes to the right. So 3 squared would just equal 9. And that's it for that example. Let's look at another one. So this one has a center at negative 2, 4. So that's my h and my k. So I have x minus h, which is minus a negative 2. So that becomes positive 2. Then I have y minus k, which is 4 for this example. And then my radius is the square root of 5. So I need to square that and then put it over here on the right side of my equation. So the square root of 5 squared is just going to equal 5. All right, so that's it for those 2. Let's look at these 2 graphs. If we're just given a graph and we have to write the equation, you should go to the center point and figure out what point that is. So it looks like it goes left 3 and up 3. So negative 3, 3 is my center point. Let me write that out here where you can see it better. The radius, you can just look from your center to the top of the circle or to the left. Like how many units is that? So that looks like 1, 2, 3, 4 units. So my radius is equal to 4. And then we just write our equation. So we would have x plus 3, because you change the sign, plus y minus 3, change the sign, equals r squared. So 4 squared is just equal to 16. All right, let's do another one of the graphing ones. So if they just give me the graph of this circle, I'm going to locate the center point. So it's at 1, negative 1. I'm going to write it out here where you can see it better. The radius looks like 1, 2, 3, 4. So we just need to write out our equation. So we say x minus 1 squared plus y plus 1 squared is equal to r squared, which is 4 squared, which I'll just put 16. Okay, in the last 2 examples, it's mentioning a translation of our x squared plus y squared equals 2 formula, moves 5 units left and 3 units down. So I like to think of this as my center point was at 0, 0, and it's shifting because that's what a translation does. It makes your graph shift to the left and down. So my new center point is going to be left 5, so that's minus 5, for my h. And 3 units down is -3. So I'm going to rewrite this equation with that center point. So it'll be x plus 5 squared plus y plus 3 squared. And then my radius would still be the same because we haven't changed that. So just leave that 2 like it is. And that's it. Let's look at one more of those. So if we have a translation of the circle x squared plus y squared equals 9, think of this center as at the origin, but it's going to move. So the new center point is 2 units to the right, which would be 2, and 4 units up, which is +4. So we just need to rewrite our equation with that new center point included. So it'll be x minus 2, remember you change the sign, plus y minus 4. So x minus 2 squared plus y minus 4 squared. And then the radius has not changed because all that happened was this circle shifted from the origin right 2 units and up 4 units. So the radius did not change. In other words, this circle did not have a dilation, at least not from what they've mentioned here. All right, so that's it for our examples of circles. Thank you for listening.